We're now going to take a look at using this map with a specific example with numbers, etc., where we can get from any one of these, from particles, mass, or moles that are given, convert to the required of moles, and then if we need to, get through to the mass or the particles. Before we start, make sure you have accessed the student guide for doing the full stoichiometry problem-solving map and printed off at least one of the templates, and there's a few you can choose from. So there is one that is fully blank, doesn't have the steps written in, and I would like you to work up to using this one after you've done a few problems using the one that's got the steps written out for you. And once you start using this one, please write out the step and then do it. So write it out in words just as it is on the more guided one that has the steps written in, so that you practice thinking through what is that actual step. Do that for 3 or 4 problems until you're comfortable, and then you can put this map away and just do the steps on your paper, not using a big layout like this, or you can just stick with doing a big layout like this and draw it out like this on a test. That's completely fine. And there are in-betweens that have more and less information on them for you to use with more and less guidance as you go. All right, so for today, for this example, I'm going to use this one that's already got the steps on it. So we can work with that. And we're going to take a look at a problem. So our problem is, how many particles of water are produced from 1 gram of oxygen in a reaction with hydrogen? So that might be the problem you see written on the page, and your job is to be able to do steps 1, 2, and 3 from that. So you're given all the information you need to pull out that it's a reaction between hydrogen and oxygen that produces water, and using all of our chemistry knowledge, we can pull out all of this information. So now we've got our balanced chemical equation there. We have our given of 1 gram of oxygen. We are looking to figure out the particles of water produced. So we need the molar mass of our given, which is oxygen, the molar mass of our required, which is water, and always, always, always write down that you know Avogadro's number, because it's not given in the problem, and you need to remember that you know that. So our first step is to identify our root now. We've got steps 1, 2, and 3 done. Do those first, then worry about the route that you're going to take on this map. So we are starting with a mass. So we're going to start over here with our 1 gram of oxygen. That's our given, so we know we're working on that side. We always have to get to here. We always have to follow through the mole conversion. And then where do we want to get to? The required is particles. So we need to get down here to particles. So that's our root. We now know we can ignore this part and ignore that part and just follow our root. So let's do that. So we've got our 1 gram of oxygen. We are going to divide it by the molar mass. So it's getting divided by the 32 grams per mole. This cancels out our grams, and we are left with 3 times 10 to the negative 2 moles. Let's convert through our molar ratio. So we're going to multiply that value by the molar ratio from the balanced chemical equation. We put our required on top. So it is 2 moles of H2O to every 1 mole of O2 in that equation. So this again is moles of O2. All right, that's our given. So the moles of O2 and our moles of O2 cancel out, and we just get 3 times 10 to the negative 2 times 2. So we have 6 times 10 to the negative 2 moles of our required, which is water. And now we need particles. So it turns out we don't even need the molar mass of water, but it's not a bad idea to get in the habit of writing that down, because maybe steps B or C needs it. So we've got our moles. We're going to convert to particles by multiplying it by Avogadro's number, 6.02 times 10 to the 23, and that is particles per mole. So when we do this multiplication, 6 times 10 to the negative 2 times 6.02 times 10 to the 23. Mole is on top, and on bottom, they cancel out, and you're left with the unit you're looking for, which is particles. And we end up with this number, 3.6 times 10 to the 22. Sorry, my writing is not quite as neat when I'm operating a little distance there, nor is it ever neat, right, if you're in my class. All right, so now we just need to consider our significant figures, and not every one of my stoichiometry videos is perfect on that, so look for the errors and see if you can correct them. But for this one, we've got 2 significant figures in our answer, but we only started out with 1. So this is a pretty big rounding, but that's the way significant figures work. So if we deal with that, we end up with 4 times 10 to the 22 is our final answer considering significant figures. Same number, same value range, just rounded to how accurate we can be. And then you would want to just wrap up with a therefore statement. All right, so do your therefore statement. 1 gram of oxygen produces 4 times 10 to the 22 particles of water, and make sure you put your mass in there and your particles in there to identify what those numbers are, and then you're done. We'll take a look at a few other versions of problems in the next video.